Okay, here's the learning target. Decompose a function given symbolically into a composition of two or more functions. So before we're having two functions, we compose and we get the result. Now we want to think of as we have a function and we want to see if we can decompose it into two functions such that if we took their composition we get that function. So our first example here is going to be the function f of x equals x squared plus 1. So if you look at it, you know you're squaring something and then you're taking something and adding 1. So you got to do a few of these, but it's kind of obvious what to do here once you've done a few of them. So I want to let my first function g of x be x squared, and then I know I have to take x squared and add 1, so I'm going to let my second function be h of x equals x plus 1, because I know I need to plug g into h to get, I need to plug x squared in there to get x squared plus 1. So let's do the composition to check it. So then h composed with g of x, so I need to do g first. I need to plug g into h. So g of x, h composed with g of x is h of g of x. H says whatever's inside of me, take that thing and add 1. So it's going to be g of x plus 1. But g of x is indeed x squared. So we have x squared plus 1. X squared plus 1 is f of x. Therefore, we're given the function f of x equals x squared plus 1. We have found two functions, g of x equals x squared and h of x equals x plus 1, such that f of x equals h composed with g of x. Let's do a second example here. We have this function, which is the absolute value of x squared minus 3 divided by x squared minus 7. Now think about what's happening in here. We're doing this quotient inside here. We have this quotient, and then after we take this quotient, we take the absolute value. So if I let my first function be the quotient inside there, x squared minus 3 divided by x squared minus 7, and then we know we need to take the absolute value of that, so we let our second function, h of x, be at the absolute value of x. Knowing that we need to plug this function g of x into h of x. So again, we want to check this in any homework or test. In this situation, the important part will be the check, showing the composition and showing that it does indeed produce f. So h composed with g of x is h of g of x, and h says whatever's inside me, take the absolute value of it. So g of x is inside of h, so we take the absolute value of g of x, but g of x equals this quotient here. So we have the absolute value of x squared minus 3 over x squared minus 7, which does indeed equal f of x. So our conclusion here is therefore f of x equals h composed with g of x, where h is the absolute value of x and g is defined as x squared minus 3 divided by x squared minus 7. Let's get another example. We have this function h of x equals x squared plus 1 over x minus 1, and then minus 1, then everything cubed. And here's our question. If g of x equals x squared plus 1 over x minus 1, then find a function f such that h equals f composed with g. Okay, so I know I'm going to be plugging g into something, and here we're taking that function g, subtracting 1, and then cubing it. So this tells me that I want my function f that I'm going to be plugging g into to simply be x minus 1 cubed. Because now think about it, if I plug g in here for x, I get h of x back. And here's the work to show it. Let's walk through it here. So we'd want to check that we do indeed have h of x, so that f is the correct function. So let's see, f composed with g of x equals f of g of x. That is, we are plugging g of x into f. But this function f we come up with says whatever's inside me, subtract 1 and then cube it. So we have g of x inside of f. So we take g of x minus 1 and cube it. But we are given that g of x is x squared plus 1 over x minus 1. So this equals, replacing g of x with its definition, we have x squared plus 1 over x minus 1 minus 1 cubed, which, looking back up here, is indeed h of x. And that will conclude this video lesson on this learning target. Thank you.